This command displays the execution plan that the PostgreSQL planner generates for the supplied statement. The execution plan shows how the tables referenced by the statement will be scanned by plain sequential scan, index scan, etc. And if multiple tables are referenced, what join algorithms will be used to bring together the required rows from each input table. The most critical part of the display is the estimated statement execution cost, which is the planner's guess at how long it will take to run the statement, measured in cost units that are arbitrary, but conventionally mean disk page fetches. Actually, two numbers are shown: the startup cost before the first row can be returned, and the total cost to return all the rows. For most queries, the total cost is what matters, but in contexts such as a subquery in exists, the planner will choose the smallest startup cost instead of the smallest total cost, since the executor will stop after getting one row anyway. Also, if you limit the number of rows to return with a limit clause, the planner makes an appropriate interpolation between the endpoint costs to estimate which plan is really the cheapest. The analyze option causes the statement to be actually executed, not only planned. Then actual runtime statistics are added to the display, including the total elapsed time expended within each plan node in milliseconds, and the total number of rows it actually returned. This is useful for seeing whether the planner's estimates are close to reality. Important: keep in mind that the statement is actually executed when the analyze option is used, although explain will discard any output that a select would return. Other side effects of the statement will happen as usual. If you wish to use explain, analyze on an insert, update, delete, create table as, or execute statement without letting the command affect your data, use this approach. Begin, explain, analyze, roll back. Only the analyze and verbose options can be specified, and only in that order, without surrounding the option list in parentheses. Prior to PostgreSQL 9.0, the unparenthesized syntax was the only one supported. It is expected that all new options will be supported only in the parenthesized syntax. Parameters: analyze. Carry out the command and show actual runtimes and other statistics. This parameter defaults to false. Verbose. Display additional information regarding the plan. Specifically, include the output column list for each node in the plan tree, schema qualify table, and function names. Always label variables and expressions within their range table alias, and always print the name of each trigger for which statistics are displayed. This parameter defaults to false. Costs. Include information on the estimated startup and total cost of each plan node, as well as the estimated number of rows and the estimated width of each row. This parameter defaults to true. Buffers. Include information on buffer usage. Specifically, include the number of shared blocks hit, read, dirtied, and written, the number of local blocks hit, read, dirtied, and written, the number of temp blocks read and written. A hit means that a read was avoided because the block was found already in cache when needed. Shared blocks contain data from regular tables and indexes. Local blocks contain data from temporary tables and indexes, while temp blocks contain short-term working data used in sorts, hashes, materialized plan nodes, and similar cases. The number of blocks dirtied indicates the number of previously unmodified blocks that were changed by this query, while the number of blocks written indicates the number of previously dirtied blocks evicted from cache by this backend during query processing. The number of blocks shown for an upper-level node includes those used by all its child nodes. In text format, only non-zero values are printed. This parameter may only be used when analyze is also enabled. It defaults to false. Timing. Include actual startup time and time spent in each node in the output. The overhead of repeatedly reading the system clock can slow down the query significantly on some systems, so it may be useful to set this parameter to false when only actual row counts and not exact times are needed. Runtime of the entire statement is always measured, even when node-level timing is turned off with this option. This parameter may only be used when analyze is also enabled. It defaults to true. Format. Specify the output format, which can be text, XML, JSON, or YAML. Non-text output contains the same information as the text output format, but is easier for programs to parse. This parameter defaults to text. Boolean. Specifies whether the selected option should be turned on or off. You can write true, on, or 1 to enable the option, and false, off, or 0 to disable it. The Boolean value can also be omitted, in which case true is assumed. Statement. Any select, insert, update, delete, values, execute, declare, or create table as statement whose execution plan you wish to see. Outputs. The command's result is a textual description of the plan selected for the statement, optionally annotated with execution statistics. Section 14.1 describes the information provided. Just a few notes. In order to allow the PostgreSQL query planner to make reasonably informed decisions when optimizing queries, the PG statistic data should be up to date for all tables used in the query. Normally, the AutoVacuum daemon will take care of that automatically. But if a table has recently had substantial changes in its contents, you might need to do a manual analyze rather than wait for AutoVacuum to catch up with the changes. In order to measure the runtime cost of each node in the execution plan, the current implementation of explain, analyze adds profiling overhead to query execution. As a result, running explain, analyze on a query can sometimes take significantly longer than executing the query normally. The amount of overhead depends on the nature of the query, as well as the platform being used. The worst case occurs for plan nodes that in themselves require very little time per execution, and on machines that have relatively slow operating system calls for obtaining the time of the day.